Today we will be seeing how IBM Db2 and System I can be monitored with Manage Engine Applications Manager. Our agenda for today is eliminating performance bottlenecks from I-Series infrastructure, business critical attributes of DB2 for I-Series, measuring performance counters of AS400 servers, and finally we will see some tips for effective capacity planning. Now, if you talk to any IT administrator, the most common challenges that we come across is the server crash or unexpected downtimes, memory leaks, and many such issues. Usually, IT admins depend on multiple tools to achieve all of these. They use scripting tool for one aspect, alerting tool for another, and monitoring tool for the purpose of monitoring various applications. So what would be the solution where an admin can perform the monitoring and identify the entire IT architecture, get real-time user experience, and identify the alerts during an outage, and have timely reports for in-depth analysis. All this is done with the help of Applications Manager, which is an agentless monitoring tool which supports monitoring of more than 100+ applications. So considering the scenario where an admin uses multiple tools, Applications Manager plays a vital role which supports monitoring of physical servers to virtual servers, cloud applications to database servers, virtualized environments to applications, and many more, along with identifying in-depth reports, analysis, and real-time user experience. All this is done in a single window pane. Now, we will see how AS400 monitor can be added and how its performance can be enhanced with the help of Applications Manager. Since Applications Manager is an agentless monitor, it requires certain prerequisites to be met. And these prerequisites include for AS400 that a user should be permitted to access QMPG data library such that a user would be able to create read-write operations and also include creating of disks or partitions or many such privileges. Also, it is recommended to use an account having a QSE COFR permission on the server. Once all these privileges are enabled, adding a monitor from the UI is pretty easy, where an admin has to specify the host information, which is a host name or the IP address, along with the credentials for that respective server. Once the monitor is added, we will see various performance counters of the AS400 servers, and they include the auxiliary storage pool utilization, which is one of the important aspects of monitoring an AS400 servers. This gives in-depth information about the total storage which has been included. Added to that, it also displays the amount of unprotected used memory and maximum unprotected memory allocated to a specific auxiliary storage pool. We also monitor the pools from an AS400 server, and these pools include various monitored metrics such as the overall pool size, reserve size, DB pages and faults, non-DB pages, and non-DB faults. Added to this, we also monitor the AS400 jobs summary, where we monitor a list of jobs which are available on the AS400 servers, and certain monitored metrics include status of the jobs, priority of the jobs, number of queues present within each job, and number of threads which are actively being used. All these monitored metrics are enabled to perform actions like end, hold, or release jobs. So this screenshot over here gives a good idea as to what critical metrics are essential for an admin to monitor in order to enhance the performance of the AS400 servers. Now, talking about any server, it is quite essential that the disk utilization is also monitored such that it lets a user identify how the disk growth has been with the help of the monitored metrics, which includes the read-write operations in the disk, identifying the disk space that has been allocated and the number of partitions which are available along with its utilization. This screenshot over here determines various information for which a user can identify how the disk is behaving at various time intervals, and also it lets a user to configure thresholds for each and individual attribute, letting a user identify the performance bottlenecks of the AS400 servers. The most important feature while monitoring an AS400 is the AS400 queues. These queues include data queues, job queues, and output queues. Now, let us go ahead and have a deeper insight from the UI to see how an admin can add a monitor, after which we will have in-depth view into one of these attributes one by one. Now, this is the home page of Applications Manager UI, where we identify the monitors which are supported for monitoring in Applications Manager. So altogether, there are more than 100 plus monitor types, which is what is displayed on the screen. Now, to add a monitor in Applications Manager, one has to go to the Admin tab, from which a user has to click on Add or Discover, where there are multiple options. For a user to add an AS400 server, one has to click on the AS400 information, after which a user has to specify custom display name and the host information and the credentials. So once all these information are provided over here, provided the privileges are enabled, a monitor would be successfully added. Once a monitor is added, we could identify the monitor status from the Monitors tab, and this particular AS400 monitor is listed under Servers, where we could identify the performance and the availability of the server. So over here, we have the overview page, which gives a good glimpse of the server snapshot, which includes the auxiliary storage pool utilization, interactive performance, and the processing unit. At the same time, we also monitor vital system stats, which include disk utilization, permanent address, and temporary address. Down below, under monitor information, we monitor or we display the monitor's health and availability status. Along with that, Applications Manager identifies the system model and the system serial. Now, coming to the monitored metrics, under Status tab, we have the auxiliary storage in-depth information, where the amount of hard disk capacity available in an AS400 system is identified. The performance of an AS400 can have a huge impact if the ASP total usage goes beyond a certain percentage, which is set with the help of the configure alarm icon. And not only that, it also identifies the amount of unprotected used memory and maximum unprotected memory for the auxiliary storage pool. Next, we will see the pools, where AS400 monitor has various default pools, which gives in-depth information for certain system pools, which includes machine, base, inter, and spool. The information provided here gives better understanding to how much of the memory allocation has been used by the jobs and how much memory is still being unused. Over here, we have the reserve size, which can affect the system's performance if insufficient memory is allocated to one of these pools. So let us say if the machine pool has an overall reserve size of 265 or 270, and if in case if the usage goes beyond 265 or any set value, it will have a direct impact on the performance. So monitoring these metrics, which includes the DB pages, DB faults, non-DB pages, and non-DB faults, lets a user identify or provide better visibility on various programs and jobs that are being executed in the AS400 server. The information which we see on the table is what we display on the graph down below, which gives granular information for various time intervals and for various pools along with its utilization. The most important monitored metric in an AS400 is the AS400 jobs. By default, we have the monitoring ability of monitoring 100 jobs, where we determine the job status with 3 different severities, and these severities include clear, critical, and warning. Now that we have all these 100 jobs listed here in the UI, in a real-time scenario, for an admin, it might not be necessary that he or she would be monitoring all these jobs. And also the fact that only certain amount of jobs which are highly business critical are required for monitoring. So an admin can choose to go ahead and optimize which jobs are required for monitoring. But before that, there is an option here which is enable or disable jobs. This particular information is where a user can tweak various settings in respect to data collection to identify what is required for monitoring on the AS400 server, be it the pool, be it the jobs or messages, queues, anything. Based on these checkboxes, the information that is applied over here is what Applications Manager lets a user monitor the chosen metrics. Now coming to the jobs. So in a real-time scenario where an admin has to monitor a specific set of jobs, a user can go ahead and click on Add Jobs to Monitor, which will list out all the jobs which are available at the time of the monitor when it is added. In order to fetch new jobs, a user can identify from the available list of jobs, which is done with the help of fetch from AS400 or iSeries. This particular option lets a user provide custom information, which is the job name, user, number of the job, or the type of the job. And these types include all active, auto start, batch, subsystem, and many such metrics. So one has to identify the business critical jobs and thereafter go ahead and choose the jobs which are required for monitoring. Now, let me go ahead and choose a couple of jobs and click on Add. So this way, once a job is added, a user can identify the number of jobs which are added for monitoring. Now, the information which was right now chosen would be reflected after the monitor has completed its polling interval. Let me poll this monitor manually to show what changes have been made. Right now, we have 3 jobs which are added for monitoring. Here, we monitor various information like the job name and the type of job, which includes batch, interactive, or auto start. We also display the number of active threads in the job along with the queue as to where an individual job is located and the name of the subsystem which holds the job. Added to that, we also monitor the total time taken for a single job for its execution. And we also monitor the temporary storage of an individual job. Added to all this, we have a configure alarm icon, and to the next of it, we have a history report of an individual job to identify how it has been performing over various time intervals. Now, the next thing which we will see right now is the disk, which could be accessed by clicking on this disk tab, where the disk status over here shows performance and the overall status information about the disk units on the system. It displays the number of units currently on the system, which includes the type of each disk unit, the size of the disk space, whether the disk is currently on the system, the percentage of the disk that is being used, the average amount of read-write operations that are being performed on the disk. We have a unit status where it identifies the individual ARM details on the disk which is available. Now, on the AS400 disk, there might be various auxiliary storage pools, and also it might have various disk partitions present within each and individual auxiliary storage pool. So this disk tab helps a user identify various information like the overall drive space which is available, the number of read-write operations which are taking place, number of ASPs which are present. Here we have various values by which we denote the number of ASPs which are present on the AS400. And these values include, like what we see on the screen right now, which is number 1 for ASP number. It indicates a unique auxiliary storage pool. But if the ASP number varies between 2 and 32, it specifies that this particular ASP is a basic ASP. And if there is a value that ranges between 33 and 255, it specifies that these auxiliary storage pools are independent. Whereas if there is a value which is 0, it indicates that the unit is currently not allocated. We also monitor the unit status, which is also the local mirroring status, that is denoted by 3 different numbers, which is 1 being active, 2 being resuming, and 3 being suspended. Now, with all these information, a user can identify as to which disk is consuming more response time or performing more read-write operations, by which a user can identify what needs to be done to enhance the performance. Next is the data queues, which could be accessed by clicking on the Queues tab. So here we have various information that could be monitored, and these queues include monitored data queues, monitored job queues, and monitored output queues. One might wonder why there is no data available on these queues. So it depends on an admin if the queues are required for monitoring. If yes, a user can go ahead and add the queues to monitor, which populates the total list of queues from the AS400 server. And these queues include data queues, job queues, and output queues. A user can choose between the existing queues or even choose to fetch from the I-Series server. Now, let me go ahead and add a couple of data queues for monitoring. So I choose 3 queues and then I click on add. This will add 3 queues for monitoring. Similarly, a user can identify if job queues and the output queues are essential. If yes, a user can click on the job queue type, and then he has to click on fetch queue, from which the job queues are listed, where an admin can once again choose between the available list of job queues to be monitored. Now we have added 3 different job queues, and we will also add similar information under output queues. So a user has to once again choose the available queues, which is by clicking on fetch queues, which populates the list from the I-Series environment, and then click on add queues. So once all these queues are added for monitoring, the information over here will be populated after a single poll interval. So we could also manually poll right now so that a user can identify the recent changes which have been made. Right now we see information for all the queues which are present over here. The data queues over here provides a fast means of inter-process communication, and it is a method which is used to pass information to another program. Applications Manager allows a user to monitor certain predefined system library data queues and objects to maintain the overall performance of an AS400 servers. Queues monitoring is of high importance to operators as they are the holding areas of messages, printed reports, batch jobs, and other work that is waiting to be received or released to the CPU or accessed by a specific user. One can perform in-depth data queue monitoring with the help of the various queues which we have added right now for monitoring. Under data queue, we identify the queue name and the library which holds the queue and the sequence from which these specific queues are retrieved. And we also monitor the object size for an individual queue and the object unchanged, which indicates that the total time taken by a single queue to be performing its operation without having its state unchanged. And this is identified in minutes. Next, we monitor the number of messages which are present on the data queue and the overall entries that will fit into the data queue before it could be extended for publishing. We also monitor the current entries which are present in the queue and the overall utilized allocation, which is used by the storage for an individual data queue. Next is the job queues, where we monitor the specific job queue as to which library it resides in and the sequence by which it determines the number of jobs that are required to be processed. And also we monitor the status, which includes released or held for an individual job queue. Under output queue, we monitor the queue's library and its sequence as to the number of spooled files which are present on the output queue. Added to that, we also monitor the individual status of the output queue, which is either the queue is released or if it is held. And we also monitor the writer and its status. Writer has various statuses like started, ended, on job queue, held, or message waiting. In the end, we also monitor a printer status for which all these queues are published to the printer which is available. Now that we saw various performance metrics on an AS400, let us go ahead and see monitoring business critical attributes for a DB2 for I series. At any point of time, should you have any questions, please feel free to put your questions in the webinar chat panel where our panelists will be able to answer these queries. Next is discovering the DB2 for I databases. So adding a DB2 for I has multiple methods. One is the IP range, where a user can provide an IP range for multiple databases to be discovered, or a user can choose to import multiple monitors with the help of a CSV file, where a user has to input values like the host information, credentials, and the polling interval. Once all these information are put together in a CSV file, it could be uploaded from the UI, and then the monitors would be discovered. Also, adding a monitor for DB2 for I series is pretty straightforward, as a user has to provide basic information like the host details and the credentials, along with a unique display name. Once the monitor is successfully added, we could monitor various information for an individual DB2 for I series. And these information includes CPU status, where we monitor the CPU utilization, overall CPU rate, and the number of configured CPUs which are available on the DB2. Next, we monitor the system information, which gives an overview of the overall auxiliary storage pool which is available within this particular database, where we have wide range of metrics that could be monitored, and also at the same time a user can provide thresholds for the same. And these metrics include reserved size, current size, threads, and the total elapsed time. For any database which is running, it is certain that there are various jobs which are performed in the backend, and these jobs include active and passive jobs. And at the same time, while monitoring the database, we also require and there is a need to identify how the memory has been utilized, and this is done with the help of the JVM, where we identify the top 10 jobs which are being run in the database by its garbage collection and by the heap usage. Now let us go ahead and see how a user can add a DB2 for I monitor from the UI, and also we will have a bird's eye view of various metrics which are monitored, which is essential to enhance the performance of the DB2 for I database. Now let me go to the admin tab, from which a user can choose to discover monitors based on their requirement, be it multiple monitors or be it a single monitor. So user can choose bulk import, where one has to choose the monitor type, which is DB2 for I, after which a predefined or already created CSV file should be uploaded, with which the monitors would be added. And also a user can choose to add a monitor individually, which is by choosing this add option, and by navigating to database servers, we have an option for DB2 for I. Once we get into this page, a user will be required to provide information like the host information, the username, and the password. Once all these fields are inputted, we would be able to add the monitor. Now let us go ahead and see the DB2 for I, which was already added, and that is listed under database servers. The DB2 for I monitor gives the availability and performance of the last 6 hours, which is seen on the overview tab. Over here, we also monitor the CPU details, which lets a user identify the average CPU utilization for all the active processors, the average CPU rate, which is expressed as percentage. So let us say if the average CPU rate is at 100%, it indicates that the CPU is running at a nominal frequency. But what if the CPU rate goes beyond 100, or let us say if it is 120%? It means that the CPU's processor has been boosted up or turboed, where it is running way beyond its assigned nominal frequency. Similarly, if the value is below 100, it indicates that the processor is running slow compared to its normal frequency. Next is the configured CPUs, where we identify the number of CPUs which are configured within this DB2 for I database. And next is the current CPU capacity, where we monitor the current processing capacity, which specifies the processor units that are being used in an individual partition. And for a partition which is sharing a physical processor, it identifies the current processing capacity, which represents the share of the physical processors which are running in the pool. With all these information, a user can identify extensively how the performance of the CPU has been on a DB2 for I database. Now let us go ahead and have a deeper insight into the system information, which includes the storage and the memory pools. Under storage, we monitor the main storage, which is the overall allocated size for this database, and the amount of ASP, which is an individual ASP storage in the system, and the amount of ASP memory which is being used at any given interval of time, the total number of partitions which are active in the system, and we also monitor the active threads. Down below, we have the memory pool information where Applications Manager monitors certain predefined system pools, which includes machine, base, interact, or spool. For each and individual pool detail, we have various monitored metrics, which includes the reserved size, which indicates the amount of storage in the pool reserved size for the system use, which is for any save or restore operations. And next is the current size, which indicates the overall storage pool size. And then we have the maximum Java threads that could be active in a single pool at any time. And we have current threads, which indicate the number of threads which are actively being used in a single pool. And under elapsed time, we monitor the overall time taken right from the origin where the thread has started its operation on the pool. Next, we will see in-depth system details, which includes the number of jobs which are running and the JVM information. Under jobs, we monitor active number of jobs, which includes the number of jobs which are started but have not yet ended. This includes both user and system jobs. We also monitor the interactive jobs in the system, where it lets a user know the overall performance of an individual logical partition. The value specifies how the performance of the disk is at any given interval of time. And next is the total jobs in system. And these jobs include all the jobs which are waiting on the queue that requires to be processed, and all the jobs which are currently active, jobs that are completed running but still have an output that needs to be extended to the output queues to be produced. Similarly, under maximum jobs in the system, we monitor the same jobs, but the difference being there is a set limit where maximum number of jobs are allowed on that system. Now, considering all these jobs which are being actively performed in the system, it is highly essential that a user identifies how much memory has been utilized by each and individual job. And this is done with the help of the top 10 jobs by garbage collection, where we monitor the jobs by garbage collection, which is identified by its top 10 consumption. We monitor the process ID to which these jobs are located, and it also identifies from which kernel this particular process is obtained. We also monitor the start time and the total garbage collection time, number of Java threads, which includes active threads, timed waiting threads, or blocked threads, many such Java threads which are available to be processed within a single job. Added to that, we also monitor the overall heap usage and heap usage for individual jobs as well. And this is done with the help of the top 10 jobs by heap usage, where we identify the job name and the process ID along with its current heap size that is being used, where we also identify the overall heap size which is allocated to this particular job. With all these metrics, a user will identify various business critical issues with the help of the number of details which we show on the UI. Now that we saw various performance metrics on certain I-series monitors, we will go ahead and see how bottlenecks can be eliminated from the same I-series infrastructure. When I say bottlenecks, I refer to the health and the availability status of the monitor. And this includes various dependencies. And these dependencies are the individual attributes like the jobs, pool, queues, JVM information, and many such attributes which are available within a monitor. And each one of these attributes are identified with various severities, which is clear, warning, and critical. And next is the availability, where a user can identify the monitor's performance with its availability. If a specific resource or a remote resource is pingable from Applications Manager installed machine. Based on its result, Applications Manager determines a monitor status as up or down. This is a sample screenshot of how a user can create thresholds, be it a string value or be it a numeric value. One has to ensure that necessary values are provided based on which Applications Manager can alert a user with the help of the threshold which is associated. Now that we saw various business critical metrics and how all these bottlenecks can be avoided, let us go ahead and see certain reports which are available and how all these can be classified and organized in a comprehensive dashboard. There are various reports available in Applications Manager, and these reports include trend analysis, forecast, or reports based on monitor types and their respective monitored metrics. This is a trend analysis report where a monitor's performance of an individual attribute can be identified at various time intervals, and they being hour of the day report or day of the week report, a heat chart. So with the help of these individual aspects, a user can identify how the trend of an individual attribute is at various time intervals. Next, we also monitor the forecast report to identify how the disk utilization or jobs utilization of the AS400 server is, or a DB2 for I database could be identified over a period of a maximum of 2 years. Next, we monitor the reports individually, where we have the ability to compare reports for multiple monitors, and also we can compare reports for multiple monitored attributes. Let us go into the UI to see how a user can create thresholds and various reports which are available. Over here, we have a threshold profile option from which a user can create new threshold profile and choose between various values which are available, be it numeric or be it string. Once necessary information is identified, a user can provide information for a specific monitor type, and then threshold values could be associated for various severities. And this particular threshold could be associated to all the monitors which are available on Applications Manager. Now let us go ahead and see how reports function in Applications Manager. So under the Reports tab, there are various reports which are available for individual monitor type. So let us choose the Trend Analysis report and search for the AS400 monitor, which has certain monitored metrics. So if we take the ASP percentage, it determines how the usage has been and predicts its trend over various time intervals. So if we choose hour of the day report, it lets a user identify various time intervals for which the ASP percentage has been on an AS400 server. And next is the forecast report. On the forecast report, a user can identify or see how it helps to right size the servers with the help of its growth trend over various time intervals. So one can choose between the servers and various monitored metrics from this dropdown, which is available over here. And we could also get a forecast report for the disk utilization of all the servers which are available, for which a user can identify how the disk growth is going to be at various time intervals, be it 1 month, be it 2 months, or be it 2 years. Now, with all these information which are manually triggered at any given time, a user can also schedule these reports at their convenience. With this, let us go ahead and see how all this information can be classified over a dashboard. When it comes to dashboard, it gives a better view of or a glimpse of the entire IT infrastructure which is available when it is added in Applications Manager. So a user can create multiple dashboards, which is what we will see in the UI right now. A dashboard can be accessed from the Home tab, and here a user can create many dashboards by pressing on New Dashboard over here, or from this Actions drop-down, a user can choose to create new dashboard and create multiple widgets within a single dashboard. Now let us go ahead and see certain performance widgets which are added in an AS400 dashboard. Now this dashboard is a real-time dashboard which refreshes once in every 10 minutes, letting an individual user know how their applications or how their monitors are performing. Not only that, these dashboards can also be exported over a custom HTML page or published on a bigger plasma screens, which lets other users also identify how their IT infrastructure is working. So publishing a dashboard can also be done with the help of the Publish Dashboard icon, which provides a custom iframe URL which could be published. Now, over this webinar, we have seen various information like monitoring business critical AS400 servers and DB2 for iDatabase, where we have seen various performance metrics and the memory information and the system status. And also with this, we have seen certain reports and dashboards and how it could be of use in a bigger scale.